Hi, welcome to Confidence Achievers Academy. Under this series of learning, we are considering chemistry in this our lesson. And what we are looking at today is determination of the atomicity of an element. How will you determine the atomicity of an element? And precise, what is an atomicity of an element? The atomicity of an element is the number of atoms that is present in one molecule of an element. And when you talk about the atomicity as the number of atoms, it can be monoatomic. That means when we say it is monoatomic, that means it has one atom in one molecule of that element. It can be diatomic. That means it has two atoms in the molecule of that element. And it can be triatomic. That means it has three atoms in the molecule of that element. And it can be polyatomic. Now, we have example of all this, but what we want to consider for this is how will you determine the atomicity of an element. Now, to determine the atomicity of an element, we have to consider the basic principle, and that is what we quickly explain here. The following should be considered to determine the atomicity of an element. We have to consider the following. The first thing you have to consider is the relative atomic mass of the element, and the second is the relative molecular mass of the element, or the vapor density of the element. Now, having known that, or having discovered or observed that, then how do you calculate the relative the atomicity of an element? Also, we should note that the relative molecular mass is 2 times the vapor density of an element. Peradventure, you are given the vapor density and you want to calculate the atomicity of an element, you can multiply the vapor density by 2. And once you multiply the vapor density by 2, that means you can have relative molecular mass to be equal to 2 times vapor density. Let's take note of that, and we are going to make use of that also when we are doing our calculation. So how will you now determine? We have this question to justify that. Determine the atomicity of each of the following elements. Now, the first one is an element with vapor density. Now, you can see the solution. What are we given? We are given the following vapor density. Vapor density to be equals to 62. Then, and relative atomic mass. The relative atomic mass to be equals to 31. Now, the atomicity is equals to relative molecular mass divided by the relative atomic mass. Now, the relative molecular mass can be determined from the vapor density that was given here, and that is relative molecular mass equals to 2 multiplied by the vapor density. So therefore, we can determine the relative molecular mass. Relative molecular mass is 2 times the vapor density that we are given here is 62, and that gives us 124. So therefore, the atomicity is going to be 124 divided by 31, and that is 4. So that means that element is a polyatomic because it has 4 atoms of the element present in the molecule. Now, the second question is an element with relative molecular mass of 160 and relative atomic mass of 80. Now, for the second question, relative molecular mass is given as 160, while the relative atomic mass is given as 80. Therefore, the atomicity is equal to relative molecular mass divided by relative atomic mass, and that gives us 160 divided by 80, and that answer is 2. That means the element has 2 atoms in the molecule. Then we have the third one, which is an element with relative molecular mass of 32 and relative atomic mass of 16. So the relative molecular mass is equals to 32 and the relative atomic mass is equals to 16. Therefore, the atomicity is equals to 32 divided by 16, and that gives us 2. Also, this has 2 atoms in the molecule of the element. Now, this is how we can determine the atomicity of an element when you are given either the vapor density of the relative molecular mass and the relative atomic mass. If you are new to this channel, ensure you subscribe to Confidence Achievers Academy. We are going to give you a lot of explanation on how to solve physics, chemistry, and mathematics questions in a way that will be very simpler for you to understand. You can see from here how it has been simplified, and further information and further calculations are also coming. Ensure to subscribe to enjoy your learning.